I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, did you hear what I said? It's all about
in particular.
I'm gonna answer the same as I did last time. You guys asked the same question. I'm just here to check what's going on.
What's going on? Is this where it's happening then? It must be.
This is where it's action. It was a little bit boring over at Gem Panda server, so I come over here.
When you come to speak to the real people,
Yeah.
not the fake
Who
ones.
knows? Maybe he sent me as an agent.
What was the conversation over there that was boring then? What was it?
I don't know. They were talking about hard drives, I guess. It was,
Oh right.
Ah,
The globe hard drives or global hard drive.
so he
more
had
sexual
to,
innuendos
yeah.
with a floppy drive and all that.
Oh, floppy. That's 80s, man. Get with it.
Yeah.
Not that low though. You had to install Windows in 1994. You had to use floppy drive. 1995, I think Windows 95 was on floppy also.
Did you have a computer back then with the floppy?
Yes, we did have that.
What was the first computer you got?
My dad had the computer when I was younger.
What was that?
You mean what type of computer it was?
Yeah.
I don't remember. I remember we used DOS. It didn't have Windows. So I was very young. I do remember Windows 3.1 and Windows 95 very well. The first computer I bought myself was probably when I was like 13, I guess.
Can you imagine a time before Windows?
I remember.
Imagine a computer without Windows.
Actually, no. I have not. I'm not that old, sort of. Yeah, no. But we have had.
You know they went to the moon
Linux computers
supposedly
as well,
on a it didn't have Windows, did it?
I don't think they. I would guess they probably uses something, some embedded system, not Windows. Definitely not Windows.
Like a Mr. Chip Game and Watch sort of computer
Pong.
system. Yeah. Pong.
I don't think so.
Well, they reckon it had about as much. The computer that had any that was, I don't know, part of this moon landing thing was.
Oh, you're talking about in the Apollo mission.
The
All I
what?
know is that I saw a video and he said it was something to do with this computer was about as much power as a calculator.
Well,
Yeah.
I think that's
Probably.
like an old calculator, not like a modern scientific calculator. That'd be like revolutionary. That. Imagine
Yeah.
what they could do there. They could almost have gone all the way to Mars if they'd have had that
Yeah.
back then.
Yeah. Yeah. Well, I mean, yeah. What's your position on the moon landings?
It's nothing special. It happened.
Oh, right.
They went to
Nothing.
the
It's
Mars.
nothing special, but it
Yeah,
happened.
landed
She
on the
just
moon.
went up to the moon. You
Yeah,
know,
yeah,
They
casual.
landed on the moon and they came back.
Yeah. Played a bit of golf.
Nice one.
Bit of golf. Drive a buggy around for a bit. Nah, nothing
Yeah,
That
there's,
else.
was
me
later
mate-
missions though.
My mate's waiting in the car. Well, I mean, sorry, the shuttle up there for
Yeah.
us, and he's going to pick us up in a minute. Drive us back.
Well, I think they that happened.
You know,
Also, they had they orbited the moon now, and they took picture of the rover tracks
oh, did they?
from when they were
Where?
there. Yes.
Just recently?
No, it was a few months. I believe it was like a few months back.
Wow. Have you
They
got any of
sent
them pictures?
I would have to look for them.
Please, please. That'd
And
be.
I'll
I'd
use
never
my
heard of
phone.
them.
Make sure you don't get any of those little animals in there either.
Yeah, but ducks
Like
or birds
lemming.
or lemons or yeah.
Rodents.
No, this is took from, what did you say, orbit around the moon.
Yeah,
Yeah.
no problem. They've seen the dark side of the moon. They've actually, I don't know if you're aware, Funk, but they've named a lot of the craters on the rear side of the moon.
On the is that the rear face?
The back side.
Yeah, the rear face of the moon, the opposite face to the one that we see.
Well, they say they've been around the back.
Well, they'd have to. If you had an orbit around it, then there'd have to be.
Yeah.
That's right, Funk, isn't it?
Sorry, I'm using my phone. If you Google moon landing rover tracks, something like that. Let me check what it was the LRO which took pictures of it.
Sorry, the what? LRO, did you say? I'm googling it right now.
Yeah, I am.
Moon rover
LRO.
tracks.
There we go. It's NASA website.
Sorry, it might. I'm gonna double check if it was there. I saw it. I don't remember. I have to check.
Struggling to load the window on my end.
I've gone to pictures. Oh, have they got close-up shots of the wheel, or is that not? Oh, look. China. Looks like China have beaten them to it. Here we go. Oh, I forget you can't see the thing, can you?
Okay. I think I've got it.
There you go. Look at
You
that.
looking?
Have you?
Hey?
Was it that China one there that I've got? We're close up
No,
of
wait.
the. Oh, China got a better.
So it says Apollo 17 landing site on the moon released September 5th, 2011.
Nah, that's not last week.
Oh, last week.
That we said last month. Sorry, a month ago, right?
Oh, I'm miles away then.
That's right, Funk.
He's probably trying to find it frantic. It's here somewhere.
See, photo. They've got a China. China are doing a fair bit, right? China lunar rover leaves tracks on the far side of the moon, right? So it might be. Are you getting confused about China? Oh, wait a minute. There's a dailymail.co.uk story here. Oh, right.
It was the LRO, yeah, Lunar Reconnaissance Orbit.
Oh,
But
yeah,
it was
I've got
a bit.
here.
It was a bit older than I thought it would. They orbited in 2009.
The footprint. Look, you can see the footprints according to this.
Maybe they could. I don't know. At least they could see the rover tracks.
No, they've got footprints and all sorts in this one. Look, it does say lunar. Oh, so lunar reconnaissance orbiter images offer sharper views, and it's got astronaut footpath.
Looks like hell of a lot of curvature on that moon, isn't there?
That China, yeah, that's what I say. They've got like it. Their orbit obviously gets a lot closer.
Yeah, that is the one I got. That.
I don't think it was China who did it.
Well,
I think
Yeah.
it was a NASA mission.
China also claimed that they germinated a seed as well on the dark side of the moon.
yeah, they've got factories growing there now. What was it? No, mushrooms were on Mars, right? Herbs and stuff they were growing on in China.
Oh, this is the web page I'm looking at. Quite a bit on there. It does say not secure, which is a bit strange.
Oh yeah.
Oh,
Being
I
that
don't think
it's,
mine even lets it open.
No, it takes a while, but it does open. And that
Yeah,
is
that's-
everything you need to know.
Expired.
It's all on there,
I
man.
just checked. Nathan's show is still boring.
Not you, Nathan.
Yeah, not you.
Moderator.
Oh, it's just you're right. It took ages to load that up.
Yeah. Look at that. You got all the like these little black little lines that they're saying. are
Yeah,
fake.
that's good. What were they doing? Wazzing about doing that sort of stuff.
Wasn't that what they were racing them buggies about
Yeah.
on fast speed?
Yeah, oh, that one
Yeah,
there.
NASA.
Look, there's a big ridge there. I didn't
NASA had
realise
some
in
good
that.
Wi-Fi.
Yeah, and they had great phone reception in the 60s as well.
Yep. Or really long telephone line.
Oh yeah.
Wow.
Well, there's this. Said it's a picture. Have you got that? I'll get this out because this is good.
And what's also good as well about that phone call they had with Nixon was that they had no delay. Better than,
They say they had way better Wi-Fi back then. I mean, that was
Yeah.
relayed through Australia, supposedly as well, because they were on that side. The moon was over there, out the way, so they had to relay it through Australia in order to get it back again. That's just the way it is. There you go. Right, now here, look at this. See this picture? It says it was during Apollo 15 that the rover was driven on the steep slopes whilst exploring a base of a mountain named, they'd already named it, Hadley
With the rear
Delta.
wheels off the ground.
In fact, at Station 6A, as Dave stepped off the rover, it started to slide down the hill. He was able to grab the rover and stabilise it with no problem. It's got the front wheels off the floor. That's pretty good at stabilising that, isn't it?
Oh, before it flies off.
Yeah. Whoa, that's a pretty light buggy, that, because he stepped off it.
That's zero gravity.
Yeah, nearly.
Well, almost, yeah. Not quite a vacuum. Are they in the vacuum there? No, they're
Well, it
actually-
must be.
aren't they?
You know how
No.
things float in vacuums? Well, that's what happens, right? Because he got off it. Started
Well,
to
that's the other
float.
issue as well, isn't it? Is that at the time they were telling us that the moon was outside of our atmosphere, but only a year ago they were telling us actually, well, it's inside our atmosphere. That's what they're saying now.
I've got a NASA clip of a lady that says when they first went there and opened the door of the unsealed unit, they doubled the atmosphere of the moon because of what they took with them, supposedly, from the inside of the lunar module.
Oh, yeah.
Let me see if I can find it for you.
Yeah, because the other issue as well is the inventory for what they actually had with them, and they didn't have enough power to power their life support systems and the flipping television broadcast.
Yeah, you can't have gas without a container, can you? You can't have a gas pressure without a container, so you can't have a vacuum right next to it.
They had the equivalent of 2 car batteries, 2 12-volt batteries with them. That supposedly
And
was
a
what
calculator.
What's vacuum in your mind, Bev? What's
Pardon?
vacuum? Well, how do you define vacuum?
Well,
Bev?
you first of all, you need to get a container with pretty strong sides on it, right? And then a pump. And you connect the pump to this chamber, and then you suck out as much stuff as you can, and then what's left inside of that thing is I call a vacuum. That's what I would call.
What's the pressure inside there?
Well, what do you mean?
What's the pressure?
How would
of
you
a
measure the
vacuum?
pressure?
By using a pressure measurement.
Okay, well
device.
let's put a pressure measurement on it then, right?
Yeah, and then what's
what's
you
it
would
reading?
define the vacuum to be?
Yeah, what's it
Yes.
reading? Well, you tell me, and we're gonna get as good a pump as we can, and we're gonna suck it out. What would be?
Well, you seem to have an idea of what's vacuum and what's pressurized system. So I wanted to ask you what you think vacuum is.
I just told
What's
you.
your definition of vacuum?
I did just tell you.
I can't use what you told me for anything. I don't know
Okay,
what
you can't.
kind
Well,
of
I can't make a
pressure you have
vacuum
in
for
there.
you either, so you can't use that. So what are you hoping to use? What's your understanding of a vacuum? And I'll tell you whether I think similar or different.
Why can't you define it?
I just
That-
did.
No, you didn't use. I am asking you for pressure.
I've never measured the pressure of a vacuum because I've never actually done that. So
So you have no
I
definition.
I
You're
would
just gonna
fit
pump
a
out
pressure
air.
gauge to it. Is that what you're suggesting?
I'm asking
But like
you
a
what
pressure
kind of-
gauges, all the
what's
pressure
limit
gauges
of-
I have start at 0 and go upwards. They don't.
Okay, so what? So what's the pressure you would define as vacuum? When is your limit from when it's vacuum
Well,
and when it's pressurized?
Okay, what do you call pressure?
Pressure, I call pressure, but what, you have a name for. You called it vacuum.
Alright.
Yeah, I'm asking you
what's
what
vacuum.
is pressure?
Because I got it all in my hand.
I'm asking you what's
That's so damn-
vacuum is, Bev.
I just have to
And
come back.
I'm trying to tell you, I can't define a vacuum because you don't know what a pressure is, right?
It doesn't matter what I think. I'm just asking you what you've.
But
how
I've told
would
you, we
define
get
vacuum.
you get a container or something, a very strong-sided container, right? And then attach a pump to it and have like a hose, so you can suck the air out of it. And then once
If
you've
I-
done that, then
Check
what
the
you
last
have
two.
left inside would be a vacuum, right? Now, what purpose would you be using it for?
That's not what I'm asking you for.
What do you mean?
was
Well,
wondering what-
I'm a practical person, right? So I've
no,
just
you
told you
are,
how we
but-
make a vacuum. Now I'm asking you, what would you be using it for?
You could just use it as a reference for measuring pressure, for example.
Okay, well, so what's pressure then in your eyes? Well, go on, give us
That's,
your definition of pressure,
force.
please.
Force over area.
Force over area as well. Can you please explain what's the force?
Force is Newton, and you divide it by the area.
Okay,
which you
please
apply the
explain
force
in
over.
Newton then.
Newton is
Alright,
basically
I'll be
if you
back.
accelerate an object, based on what mass it has, it's gonna.
Okay, to accelerate an
gonna
object. So
move.
we're talking about the object being the lack of anything in there because we've just extracted air, have we? From a
Did you
thing.
extract everything, or
Well, it
is it zero?
depends on how good the pump is, right? How good's the pump that we're using? How big's the container? What is this? What do you mean by vacuum? What are you using it for?
So your definition of vacuum is based on what equipment you use to create the vacuum.
It's what we can practically do. Yeah.
So vacuum can be anything from very high, from 0.9 bar to 0 bar.
Please explain a bar. What's that?
Bar is pressure.
Okay. So what's pressure then? So your force thing. Force over
I already
area.
explained what pressure was.
Yeah, you didn't explain it very well. Force over something, and then you said newtons. And newtons is things. What?
Making things move.
Making things move. Okay, so that's the force that making things move that you're measuring. So what are you measuring then within the vacuum when we've extracted it?
You can, for example, have something which counteracts the force which is applied by the gas. Can, for example, be something which is a bit flexible, and when you apply a little bit force on that, it's gonna flex a little bit. If you apply a lot of force on it,
What's going to flex?
It could be a membrane or something.
We're just dealing with the vacuum now, right? We've got a big chamber and a pump,
Yeah.
right? And we've extracted as much stuff out. So what are you talking about, please? The membrane. Which membrane?
It could be, for example, a normal way to measure pressure would be to have a flexible membrane between two pressure systems. And if you remove one of them, then you're gonna have the other side pressing against. So you can extract some kind of.
So we in order
value
what we
from
need to
that.
do is we need to put a barrier in between two different pressure systems and measure with your gauge the difference between the two, right? So it would be a relative pressure gauge.
That's the differential. Yes.
Okay.
In this case, I explained you how that would work.
So first of all, we need a container to make the vacuum, and then in order to measure the pressure thing you've just said, we need to make another barrier between the two, so we can measure the difference between the two, right?
Another way would be to have a spring, which is when you're pressing on the spring, if the spring compresses, that's relative. That's a relation to the force which is applied to the spring.
Do springs compress and I don't know what's the opposite of that? Extend in a vacuum any different? Would them being in a vacuum make any difference?
Well, if you have it in normal air, it would compress. If you put it in vacuum, it won't compress. Basically, almost zero force.
Right. So are you saying the weight of the air compresses the spring, or the pressure of the air compresses the spring?
Pressure of the air.
Okay. So a normal spring, when put into a vacuum, would extend, would it? Would it grow?
What do you think, Bev?
I wouldn't expect any difference in a spring, to tell you the truth. But I mean, it sounds interesting. Have you ever done this? Did you film it?
No, I didn't bring a camera with me.
No. Okay, so you have done it though.
Yes, I have used a lot of different pressure.
And you watched springs grow within a vacuum.
No, I haven't used a spring pressure measurement tool because in the industry, mostly what is useful for practical purposes, differential pressure. It's very few instances where you would need to know the absolute pressure.
Yeah, I mean that one makes that. Yeah, I've I understand completely that method between the two. What intrigues me is the spring extending in. Does that mean that if you get a spring and say put it in water, it compresses even more?
Yes, it would. This spring system, it's very important that if you had a spring system and you had air behind the leaking.
No, wait a minute. When you
spring.
say spring system, right, I'm just imagining a spring. That's what you've led me to believe. A spring, like a coiled piece of wire, right, that gets taller in a vacuum and smaller underwater. Am I mistaken? Or is that not what you've just said? Are you checking with the guys?
It was some connection issues.
Oh, convenient.
It's a spring with the surface area attached to it. And
Sorry, a spring with a surface area attached
surface
to it.
area.
Well, it has a
Yeah,
surface
in front
area,
of
right?
it.
It's a three-dimensional object, right? So
Yeah.
that has a surface area of its own. Is that what
Yes.
you're talking about?
No. I'm
Oh.
talking about having a plate, for example.
Okay.
You can have a square plate attached on the top of the spring.
Oh, on the top of it.
Yeah,
And then
or-
it would have to have something on the bottom to orientate the top bit on it. So can we say it's got two plates on either end of the spring?
yes, you could say
Okay.
it's attached to whatever you want to it in the bottom.
Okay,
It's,
now, is that it? Just a spring with some plates
yeah.
on it, right? How have we got a size? Do you want to give us some measurements of how big the spring is, and maybe coil, and how big
Depends on
this
what you're
surface
gonna
area
measure.
thing? Well, we are measuring, aren't we? The vacuum pressure and
Yes.
the air pressure and the water pressure. And is this how we measure how much spring? If you do that and put these plates on the top and the bottom of the spring and then put it in a vacuum and underwater, we would then see it get taller and smaller.
It would
we?
compress more in the water, yeah. But it's important that the area behind the spring is sealed off, because if you, for example, put it into water and the water leaks in behind the plate, if the water fills up, the pressure is gonna go in the opposite direction as well.
Plate,
And
sorry.
can't-
It's just a spring with a bit of metal on the top of
With
it. Right?
Yeah, plate.
Yeah. But you've not put a size to that plate. a size
You
to
can
the
make
spring.
it whatever size you want to,
Okay.
because you're gonna,
Scalable. Let's say
Yeah.
a centimetre squared little plate on top and the
Sure.
bottom of it. Let's have about
Sure.
a 2 centimetre spring.
sure.
Okay. And that's in air. Right, so it's 2 centimetres tall, or 20 millimetres. Exactly.
Sure.
Right? So in between the very top of the top plate and the very bottom of the bottom plate. So the overall dimension, total, 20 millimetres, bang on. In reality.
Sure.
Right? Now, we're going to put that in a vacuum. starts sucking air out.
Sure.
But it's right up against them. We've got a measuring device on the back of it, and we've got a camera all fitted and everything. So as we start sucking air out, how soon is it before it starts growing?
When you suck the air out,
Yeah.
it's gonna start growing instantly. As the pressure drops, it's gonna stop. It's gonna apply less force on the spring.
Okay, and it will start growing, will it?
Well, obviously,
Yeah.
since there is less pressure on it.
Okay, so so we've gone from it being full of air, and let's say we've got a pretty good pump, and say we get to 90% of what we did have in the thing because we've sucked it out. We can obviously measure how much we know the volume of it. We can calculate that, so we know when we've extracted 90% of it. So, and it was, remember, 20 millimeters. What do you think it would be at like 90%?
Depends on how strong the spring is.
Oh, so but you said before it wasn't. It's only a 20 centimeter thing, and it's only got 1 centimeter little bits on the top of it.
Yes.
Well, what would be the maximum? Like of your gauge of your spring, what would be the best that we could get to show us the most? Because obviously we're trying to make a gauge here, right? To understand how pressure works within a vacuum. This is yours, so you've already done this.
Not in a vacuum chamber, no.
Oh, did you do it under the water? Well,
I have measured both pressure, temperature of gases, air, and water, other liquids as well.
okay. So, when Have we finished with the vacuum then? Because you don't seem to know how much of, if say it was just a normal coiled spring that you see that's about 20 centimeters long. Obviously it's got these little plates on the top of it. It can't be that much to crush them, to crush the spring. So
depends on. I can calculate.
What was the maximum amount of movement you got out of a spring?
You said it was 2 inches long.
2 centimeters, 20 millimeters. Yeah, 20 millimeters. Where are you from?
I'm actually using SI, so it's better to use SI.
Right, are you from America? You want to use inches?
No, I use SI unit.
What's that?
Centimeter, meter,
Well, that's
kilogram.
what we was doing. 2 centimeters, 20 millimeters.
Yeah, that's what I said.
Yeah, but you asked me if it was 2 inches.
I thought you said 2 inches, but you said 2 centimeters.
Yeah, 20 millimeter. What's the maximum that you've had a spring move due to pressure difference?
What's the maximum
Yeah, what's the maximum amount of movement that you've ever got out of a spring?
on a spring?
Yeah, due to the pressure movement.
It's not the instruments I have used are not spring. It's not a spring in that sense.
Well,
It's
why did you bring it up
it's a
then?
membrane type. I just gave you an example of a pressure measurement.
Yeah, but then we just worked all the way through it to find out that you don't really know what you're talking about, and you've just made it up.
I didn't make it up.
So
It's,
you've
uh,
only
quite
ever
normal- it's a
seen
normal way
these
to measure pressure.
things, these springs, because you showed me it was a spring with a little plate on the top of it and the bottom, didn't you?
Yeah.
Hmm.
Yes.
So you've seen them then? The scientific things. Can you point us in the direction of the...
I can find you an example of what I'm talking about.
Okay. Please. I'm still trying to find that. A video of that woman from NASA. It must have been ages ago. Because this is what you were trying to explain, was it? Pressure and a vacuum? Oh, there you go. Oh. It's only 20 odd seconds. Oh, look at that, 3 meg. There you go, in the live stream for anybody that was listening to us before. Am I clipping? Does that sound okay?
In fact, the moon does have a little bit of an atmosphere, but the atmosphere of the moon is so small that when the Apollo capsule landed and opened up the door and let out the air that was inside, it doubled the entire moon's atmosphere. The Apollo capsule landed and opened up the door and let out the air that was inside, it doubled the entire moon's atmosphere.
Doubled the entire moon's atmosphere when they opened the door and let the air out. You imagine that? The force that must have come out of that. Pressure difference. Like they doubled the entire moon's atmosphere. Oh, well, that's before, obviously. Before it had the Earth's atmosphere as well. And so perhaps that might be why enough moon missions they took the atmosphere of the Earth over the... Maybe that's what they mean. Maybe. Yeah, you're okay with funk? You got lost?
Yeah. You
You've-
can Google Borden tube pressure gauges.
Sorry?
They are I'm gonna write
Borg.
Borden.
The Star
not sure
Trek.
how you-
The Star Trek. The Borg.
Yes.
No, not Borg. Surely. Borg technology. You're not going to call on Borg technology for
Borden
pressure
tube.
gauges.
I wrote it instead. It's a spring diaphragm pressure gauge. Mostly these spring sensors are used for higher pressure measurements.
Yeah, well, I would imagine that you have one pressure on one side of the plate and the other pressure on the other side, right?
Yeah.
Yeah. Yeah, so you don't put it in a vacuum, do you? The spring.
You could put
the
it,
spring,
then you have only
the spring
pressure on
won't
one side
grow
and you
in a
have less-
vacuum, will it?
Then you have more pressure on one side and less pressure on the other side. And the less pressure is the vacuum.
Yeah, it's just like a weight thing, right?
Yeah. Then the side with more pressure is gonna push. But if you have if you have one atmosphere on each side of the differential pressure, it's going to read 0 because the pressure is the same. It pushes the same force on each side. If you remove the pressure on one side, the one with the pressure is going to push.
Yeah, relative to the other one, right?
Yeah,
So again,
and the
it's a
other one
relative.
is, in this case,
Yeah.
in this case, it's a vacuum, so it's no pressure on that side.
No pressure.
Yes.
Okay. So you say that you could get to no pressure on one side.
Well, not. I don't think you can get to exactly 0, but very close.
Well, yeah. Right. Well, here we go. Like when we went to my my car tire, I have to keep pumping it up, and I put the gauge on. It starts at 0. Does that mean there's a vacuum already in the tire?
No. I can explain again what I meant. I just said now, if you have the same pressure on each side, it's going to read 0 because there is 0 force.
Right, so it's relative then.
That's a relative way of measuring it, yeah.
Yeah. Okay, so in order to know one, we have to know the relative difference of the other, right? So what's the original pressure then that we're starting off with? Is that were we going to call
like,
that? Do we call that 0?
You mean like the golden weight of like what's the absolute pressure? You mean?
Well, no, I'm saying if we start at 0, right?
Yes.
And when I pump air into my tire, it goes up and it gets to like 40, right? Then if we're taking air away and starting at 0, are you going to go to minus on your scale that you've just said? Because we start at 0, right?
0,
because it's relative.
If it starts at 0, then it's gonna go to negative, yeah, because you're gonna have the pressure going in the opposite way.
Mm-hmm. So you have like
if you
extracting any air out of a vacuum would then make a negative.
Well, there's no such thing as negative pressure, but you can.
Yeah, there is if you start from 0, right? I mean, like if you start from 0 and go up, and then you start from 0 and start taking away, you must go negative on your scale that you've just described.
It's just a calibration of the instrument depending on what you want to show.
Yeah, relative.
Yeah. But it's still the same physicality to it.
Yeah.
For example, you can have a differential pressure sensor calibrated so that you start at, let's say it's give 4 to 20 milliamps out. The 4 is the minimum reading you have. And if you say that 4 milliamps is 1 bar pressure, and 100 bar is 20 milliamps, and then you have a scale there. But if you remove, if you attach a vacuum pump,
that's electrical, right?
And it shows if you attach a vacuum pump to that pressure and you remove it, so it's becoming less than 1 bar, it's not going to be able to present that because the minimum reading the instrument can give is 4 milliamps. But you could, for example, say, well, 1 bar is at 10 milliamps. Or you could say...
that's an electrical, right? Are you equating a pressure reading with an electrical?
It's just a way of reading pressure from an instrument, for example. It's very normal. So it's just scaling. You read the same thing. It's just the scaling.
Do you want to have a look in the debate discussion? Right, because I think that's where you came in, wasn't it? When I said that lady from NASA said that the pressure, was it the atmosphere of the moon was doubled. Have a little listen to it. NASA Science Live.
Fact, the moon does have a little bit of an atmosphere, but the atmosphere of the moon is so small that when the Apollo capsule landed and opened up the door and let out the air that was inside, it doubled the entire moon's atmosphere.
I understand
The
what she
Apollo
said.
capsule landed and opened up the door and let out the air that was inside, it doubled the entire moon's atmosphere.
Yeah, cool, right?
Cool.
That's before they said that the moon is actually in the Earth's atmosphere still, right?
You mean in the exosphere?
No, the moon's in the atmosphere, right?
Yeah, what's atmosphere in your mind?
Like what she's just said, right? Hasn't she? It doubled
what's your-
because they opened the door. So it's
Yeah.
obviously then, right, the pressure that was within that capsule must have been, what do you reckon the relative pressure must have been from inside that capsule to outside of that
What?
capsule? If when they opened the
About
door,
1 bar.
they doubled the pressure of the entire moon in her mind.
I believe she said you got to double the amount of gases on the moon, though.
Yeah. So what do you reckon the relative pressure difference must have been?
I
If
believe
they
it's
had
very small.
they had like the same amount within that little capsule as they had over the entire surface of your moon rock.
Yeah.
I think it must have been massive, right? The relative
Very
pressure
little,
difference.
The relative pressure difference isn't that much, though. It's just 1 bar.
Yeah. Do you think it was a pressurized container that they had? That they went there in, or the one that they say they went there in?
The moon lander.
Yeah.
Yeah, it's one. I guess it was 1 bar in there.
I heard them say that they had to be careful because they might put the finger through the foil on the outside because they had to save for weight. So I heard that it wasn't actually pressurized. They had to be in the suits because that little thing wasn't pressurized. They couldn't. There was no like little toilet in it. So when they left from the other one, from the guy that's supposedly going round the outside, they left for 3 days. They were in their suits. Must have
I
stunk.
believe it was It was pressurized because they have to eat and drink and all that.
Yeah, you'd have thought
They
so,
cannot
right?
do that. Yeah, so it was pressurized.
Right, so every time they repressurized it and whatever, they would have added twice as much. Well, obviously the first time they'd have doubled it, and then they'd have had to go in whenever they needed a poo or have your food or whatever and repressurized it, right, and then open the door again, and what it
They
would have
only
like
did
a
it-
third.
they only-
They would have had like a third next time.
You mean on the third trip?
No, you said it was a pressurized unit and they had to eat their food. Because they were on there for
but
supposedly
they-
3 days, weren't they? Playing
they
golf,
landed,
building the cars. Sweaty
yeah.
work.
At that trip, they probably, I guess, the repressurized system, they would have to do that. Yeah.
Yeah. You guess. You don't know.
I can check.
You know, like sort of this sort of stuff that you keep saying about repressurizing. You're talking. What sort of pressure do you reckon you're talking about? You're talking about the pressure
bar.
that you imagine that keeps our blood and all of that within our bodies, right? Stops us from boiling.
It's
The liquids within us from boiling and steaming off and us going crazy. Because that's what it's supposedly like in the vacuum of space, right? And then to pressurize it, you're going to need quite a lot. The pressure difference, right? The differential between an infinite expanding vacuum.
It's 1 bar, the difference.
Yeah, it should be easy, right? It's only 1. You've called it 1. The difference between
1 bar.
Yeah.
That's what you would read.
Yeah. So they go in there and they go out and they play the golf and they do the little driving about in the buggies and all of that sort of stuff. And then they go in, they need to go to have a poo and have some food, sit down for the tea. So they go back into the little thing and they repressurize it, take the little space suits off, chill out, put the slippers on, have the food, clean up a bit, and put the space suits back on, and then back out to work again outside. Bit more golf. Drive around a bit. You imagine that's what happens.
I can check. It was the Apollo 15 mission. I don't know so much about.
Oh, it's only the Apollo 15 that you don't know about.
No, I don't know everything about it. No.
Okay. So, are we going to end the pressure?
What you're talking about? What about the pressure?
Well, I don't know. Like that's what you came in to ask, wasn't it? Something about a vacuum. Whether I knew what a vacuum was, or what was my idea.
I was asking you what's your definition of vacuum is. What?
Yeah, it's like
pressure.
You have to get a container and extract as much out of it as possible. Now, the more you can extract, the stronger the sides of your container are going to need to be, and the better the pump is going to need to be, because I'd imagine it gets. Sorry.
When is it vacuum and when is it not vacuum?
What do you mean? It's a vacuum when you start extracting.
As soon as if you have 1 atmosphere, if you have 99%.
Are you putting a 1? Is a 1 what we start off with?
1.
Not 0, or are you starting off with 0?
I would say it's more. It's better for this to use to. What is 0 in your mind?
I don't know. Zero is what you start from.
So what's your unit? 0 what?
Well, like in the pump that I have on my car for putting pressure into my tyre, it's pounds per square inch, isn't it?
Yes, but what's your unit?
Pounds per square inch.
Yeah, okay.
That's what it reads on the dial.
So
it's just a representation of how much air I need to put into the tyre.
It reads 0.
It starts off at 0 when my tyre's flat. Yes, it does.
Yeah. If you add something, if you add air, it's going to be a positive number.
Yep.
If you remove air, it's going to be a negative number.
Yeah, but I wouldn't be removing air from my tyre, would I? I mean, isn't this where you came in, right? Because you asked me what I imagine a vacuum was. I then told you what I imagine a vacuum to be, or whatever.
Yeah.
Then you said, what about pressure? And I said, well, what are you talking about? Pressure. I asked you to define that, and then we came up with an agreement that it was just relative of the difference between one side and another, but there's a barrier in between. Now, however you have that barrier becomes the measurement device for deciding what the difference is between one side of the barrier and the other, right? That is your pressure gauge.
I agree.
Right, so now what unit do you want to add to it? Well, that's up to you, isn't it? Like, well, once we agree on a unit, and then we can work out how far 1 goes, and it goes up to 2, and what does 2 mean in relative to 1? Like, and which side of the scale does it go on?
Yeah. It's
Like, does it, or will it always show the pressure on one side of the scale? Because would the other one that's pressing on it always be pressing on one side? So that would be a positive number. It would just swap which side of the barrier the positive number would be on, wouldn't it?
Yes, I agree. That's totally
Okay.
sure. Yeah.
So,
That's why I'm saying
your
it's
pressure
no such
thing
thing
is...
as, that's why I'm saying to you, it's not something. It's not. There's nothing that is called negative pressure. It's actually just pressure, just in the opposite direction.
Well done.
All
Right, so it's like an equilibrium in the middle where there's no difference. Right, but you just call that 0, don't you?
You can. Yeah, it depends on how you scale it.
Or do you not call it 0? I mean, I do. I just call it 0. I call that normal.
Depends on what you're going to use it for. When I say 1 bar, I mean relative to absolute pressure, 0 pressure, absolute pressure measurement, basically.
Well, go on. Explain that to us. Absolute pressure measurement. Give us a... Because we've just decided that it's just relative.
0.
So what's your absolute? Yeah, but how do you get to 0? Like we've just said, 0 is a difference between the two.
Yes.
It's when there is no difference between the two. Because that's what you have
difference.
when there is no container. There's no barrier.
But the thing is,
You have a pressure
thing is, you cannot
equalization.
do anything more than removing all the air. You can't remove even more air. If you have removed all the air, that's your absolute pressure.
Right, so you know how to do that, do you?
We have devices who have where it has already been done. If you want to.
Not on
use
Earth,
that.
you don't. No. Where do you have devices that do this?
Who can measure absolute pressure? Yeah.
Yeah. Where, please?
You can buy them.
What, on Earth, like on where you live
Of
in
course.
reality.
Yes.
Right, so you can get to 0.
It's very close to 0, but it's built in the measurements.
Sorry,
Accuracy.
measurements. Like, again, are you talking about a vacuum chamber?
It's a tiny vacuum chamber, yeah, inside that instrument.
A tiny vacuum chamber within an instrument.
And Google absolute pressure devices or something, you're gonna find something on it.
Is this your source? Google.
No, you can. I have used it at work before, but
Okay, well, give us a link to you, or like, give us a picture of the device so we know what we're looking for.
okay, I'm gonna find something for you.
Yes, please. Oh, Cleary's here. Cleary will be interested in this. We're talking about pressure, Cleary.
Yeah, I've got jets flying over me right here.
Oh, nice.
It's really loud.
Yeah, Funk's given us a lesson in, well, not a lesson. We're just sort of a bit of a think tank thing, right, Funk? You're joining in. We're trying to clear our heads on what exactly pressure is.
Talking about PSI absolute.
Well, I mean, we've managed to suss out that pressure can only really be measured as a relative difference between two different pressures. We can't really establish a like what pressure is. We can just establish that there is a difference, and the difference, you need a container with a barrier, and that normally on where the barrier is at some point, there is some sort of a device that measures the difference between the pressure on one side and the pressure on the other. Now, I don't know whether it's a difference or just sort of a, you know, how much the material bends or how much a spring compresses or whatever. But, I mean, yeah, you don't ever get to a negative, right? Because it's only a relative difference of pressure on either side. So one has a push, that's the one with more pressure, and the one with less pressure has less push, so it gets pushed out the way, right? So it doesn't really matter, but on one side of it you'll have the positive and the other side you'll have the negative. And if you don't have either, then you have zero difference, and then you can just remove the barrier and it won't make any difference.
Yes, that's true.
Yeah.
I posted a link to a company which sells these devices.
So would you agree then, for in order to have a pressure on one side, then the other side, you would need a container?
Obviously, if you're going to use it in our atmosphere.
Yeah.
Yeah. You don't have to, though, because you can also measure pressure. I'm talking about absolute pressure measurement now. But if you're talking about the differential pressure measurement, you can measure relative to our atmosphere, for example.
Yeah.
Then it's not. Then it's just in free air on one side, and then you measure the pressure on the other side.
What of? Yeah, it's always like, yeah, you need a container, right?
No, and not in the example I gave you now.
Well, in order to measure a difference in pressure, then you have to have something within a container that is a different pressure than
you could
the other side, right? I mean, is that not what we just established? Like a pressure gauge or whatever has to have two different pressures on either side of it. Otherwise, what does it measure?
The other side could be measuring pressure from whatever source you want. It could be a container, it could be water as well, it could be something else, a liquid. And the other side, that could be our atmosphere. Then you would have to, if you want to know absolute pressure, you would have to subtract the pressure which the atmosphere is creating.
Yeah, I think that sounded a little bit waffly there. But basically, we need a barrier in order to measure.
Yeah, it's normal to have as I said, like some kind of membrane or diaphragm or something.
Yeah, but you can't just hold that diaphragm up, can you?
It's obviously attached to some electronic measurement instruments to measure that.
Yeah, but it needs to measure some sort of a push on one side. Right, now, you couldn't just blow on it, could you? Well, you wouldn't say, ooh, that's measuring a pressure difference if I blow on it.
Yeah.
From one side.
If you blow hard enough, it's going to show a reading, yeah.
Okay, so would that make one side of it with more pressure than the other?
Yes.
Yes.
Because you're blowing.
Would that make the other side a form of vacuum?
No, it's just less pressure than the other
so,
side.
like when an aeroplane's flying along, I've got to make a brew. But you know how an aeroplane works. Would you call that like a vacuum? That's would that be pushing? Because the air moves faster over the top, slower underneath, so there's more pressure on top, less pressure underneath.
Yes.
Yeah.
I
so
agree.
Would you class that as a vacuum?
We agree on everything now, but we agree on everything now. So I think actually, if you want to, we can move to another topic we are not disagreeing on anything. So I guess we can
well,
just
brilliant.
move
I
on.
mean, like, yeah, okay. So we agree that you need a container.
If you're gonna have a pressure in our atmosphere which is different than our atmospheric pressure, then you need a container. Yes.
And if you wanted to create a vacuum, you'd need a container to stop the pressure from going into, right?
At the sea level or on the surface of the earth, then yeah. You have
Sorry, on the surface of the earth.
You have 1 bar pressure. It's gonna go into the vacuum if you don't contain it.
Okay. That's good. So when when they supposedly go up in a rocket, then how much pressure do you reckon they take with them?
What did you say? Sorry, you dropped out.
When they supposedly go up in rockets,
Yes.
the astronauts,
Yeah.
that when they go up, how much pressure do you reckon they take with them?
I would guess they would have 1 atmosphere. That's the one we have here on Earth.
Do you reckon they
So it's no point in
might
having
upset the
another.
balance that they have in the vacuum out there? I reckon that's not dangerous to go taking pressure up there?
No, you just have to seal the spacecraft, and it's no problem. It's no difference than making a vacuum chamber here. And also, if you have
You know that? Have you seen that one?
have some,
That big vacuum chamber that they've got.
I have seen some, yeah.
Have you seen the
I have
size
seen
of the
some
walls on it?
The one on the I'm not sure which one you're talking about. Actually,
The one that
I've seen several.
Lion Brian, what was it? They had a BBC one where they dropped a feather and a beach ball. It's like, is it the big NASA test chamber?
Yeah, they have a test chamber.
Yeah, and where they have, like, I don't know, loads of metal, and then they have concrete barriers, and then a metal bit, and then another 6 foot of concrete. And they can only pull a certain amount of vacuum because they reckon air gets pulled through the concrete and through the steel.
Yeah,
That one.
It's probably gonna leak out.
Yeah. Well, what sort of vacuum they reckon they can get when they pull that one? The difference.
The difference in pressure.
Yeah.
It's 1 bar.
What? 1 bar that they pull in that little chamber.
It's a 1 bar difference between the outside and the inside.
Is that the same as what they have in your supposed ISS?
Yeah,
Is
but
that
it's
1
the
bar
opposite, though.
again?
But it's the opposite though, because they already have 1 bar inside the structure.
Yeah, that's what they have.
And then you have 0 on the outside.
Yeah. Oh, they have 0 on the outside. Is that what like when they make that vacuum, like we've just said, the NASA one? They have, what do they have on the outside of that? What do we have? A
1 bar.
1 bar, right? So what can they make on the inside of that
They
big
try to
vacuum
make
chamber?
it as close to vacuum as possible.
As 0, do you reckon? Do you reckon they get anywhere near 0?
I think they get near 0, yeah.
Near 0. But in order to do that, they need them pumps and, I don't know, about 12 foot of concrete, couple of metal liners
Yeah.
Yeah.
to stop the air from being sucked into that chamber.
Yeah.
I did. That's new information for me, but that could be true. Yeah.
Yeah.
I didn't know. I haven't actually.
Got a question for
Yes. Yeah.
What is 1 bar? Because you keep on saying 1 bar. What's the pressure difference with 1 bar? So
You want
understand
unit in like kilogram per
Just
per
give us an
square
idea what it is, please.
meter. Sure, you can bring it.
Is it 14.7 psi?
That could be about right. It's
Okay, that sounds good. 14.7 pounds per square inch. That's relatable, right? So that's what you have on the outside of the vacuum, the big, massive vacuum chamber, right? That's on the outside, and when they start the pumps up and everything, they close the doors and they start sucking all of the air out from inside that chamber.
Yes.
Then what sort of difference do you reckon they can get down to?
About 1 bar.
You just said 14.7 is 1 bar. So that's a rubbish vacuum if they start it up and get the exact same as it is on the outside. They'd be going like, nothing's happening. We're not sucking anything out.
They sucked all the air out.
And then they get to 1 bar.
No.
No.
You have 1 bar on the outside and you have 1 bar in the inside.
Yeah.
You suck the air out.
Yeah.
Then it's 0 bar on the inside.
Right.
It's 1 bar on the outside. It's 1 bar difference.
Right.
1 minus 0 is 1.
Yeah. So they can't make. I'll tell you now. They can't make 0 in that chamber.
So I said close to 0.
No, it's not. It's not even close. Do you know how vacuums work? Do you know how vacuums work? It's exponential growth, right? The difference. But anyway, right, in order for them to get where they get, right, in that particular vacuum chamber, they need about 12 foot thick of concrete and a couple of metal liners to stop the air from being sucked through all of that into the chamber to make a vacuum chamber. Right now, you've got people that you pretend are up there floating about in little tin cans that you imagine have 14.7 1 bar of pressure on the inside, and the outside of it is a near perfect vacuum. It's near 0, but you can't even get that on Earth in reality with 12 foot thick walls. Now, how thick are the walls on the ISS, do you reckon? Because remember, this pressure is in the opposite direction. This pressure is trying to expand.
That's actually
into.
That's actually easier to contain if you expand. It's harder to resist when you're trying to compress it, because by expanding it you are stretching the metal.
No, you have a structure.
If you're gonna compress.
Yeah, you have a structure called a circle, a dome, right? That is one of the best at resisting pressure. That's why all of the under the water craft have
tanks.
Domed. Yes, they're domed,
yes.
Right? Now you go in the opposite direction.
You mean here on Earth?
No, I'm talking about in what you've just explained. The lady says that when they opened the door, it doubled the so-called atmosphere on the moon. So the pressure, 14.7 pounds per square inch, 1 bar as you call it, is on the inside. It's trying to expand into the nothing vacuum, which is much stronger than the vacuum we can get on Earth.
It's still just 1 bar, though.
Still just 1 bar.
It's more pressure than your tire pressure. Your tire pressure has more pressure than what's inside the air.
I don't think you understand vacuums, my friend.
you measure, if you're gonna figure out what force is driving on the wall,
You will.
you need to measure the differential pressure, and that's 1 bar.
Yeah, but vacuums work in a very, very different way.
What's special about that?
Well, if you
Why
ever
doesn't it work
you
like
you have dealt with vacuums, I presume.
I've dealt with the vacuum measurement tool and absolute pressure measurement.
Have you ever dealt with vacuums in a practical use? Ever?
Only for measurement, only for measuring pressure.
Okay, well, we had a vacuum chamber where I used to work, and we used to vacuum chill lettuces. So we used to pile stacks of pallets of lettuce onto this. We could get about 5 or 6 pallets. Redmond will know what we're talking about. We put them in there, you shut the thing, you fire it up, and it creates a vacuum inside it. It's vacuum chilled, vacuum cooled lettuce. And because of the vacuum, obviously, it cools it, and then the water condenses, so you end up extracting water out of the lettuce. Stops it from wilting, gives it a bit of extra life, but also chills it. Now, you don't mess about with these sort of things. If you got stuck inside that, you'd die. That you don't play with a vacuum. It's not like a pressure hose that you can add pressure and, inflate a car tyre with. A vacuum is a very different thing, and you shouldn't play with them lightly or pretend that 1 bar of pressure as opposed to 0 is nothing. It's only 1. It means nothing to you because it's just a number that you've just put there. Doesn't actually mean anything because, like you say, you don't really understand the difference between the pressure.
I have filled up 2 bar in my tire, and it's 1 bar in our atmosphere. So yeah, I have dealt with that kind of pressure difference.
Yeah, you don't understand. But I mean that's
you're not
okay because
really
a lot of people don't understand.
What kind of force is
Force.
going? It's happening.
What's a force?
Yes, what kind of?
Please explain force.
It's the units which we are dealing with now.
A force is a unit.
Yeah, because you said
That's a weight.
you used.
A pound is a weight. It's not a force, it's a weight.
So you're dealing with the same thing. I'm telling you. You cannot say you're surprised.
No. It like you can understand a pound per square inch. Put a weight of a pound and get a square inch.
Yeah.
Yeah.
That's PSI.
And then put the
PSI.
weight on the square inch area and see what it does. See what it feels like. Hold it in your hand.
Yeah. That's 14.1 PSI. That's the. That's the
number you've give it.
That's the force
Of
which
what?
is applied
The force
to
of
the
what,
walls
please?
of the vacuum chamber. The force of the air. The air pressure.
And how do you know that is the force of the air that pushes on the side of the vacuum chamber? Because you can't make a 0 on the inside. So how can you tell that it's 14.7 pounds on the outside?
How you can know that it's 14.1 psi? I'm not sure actually how they can calibrate this very precisely. Maybe they have somewhere some other way to weigh the air. Maybe you compress it to liquid.
That's a
It's
good
maybe
one.
more
Do
precise.
they have a way to weigh air? It's a good question.
Yes. Yeah.
Good question.
Can,
DP, we'll have to remember that one. That's one of the questions. Cleary, that's it. That's another one.
But you
of yours,
haven't
isn't it?
really explained why you think it's something magical going on with vacuum, and you
It's
haven't
just a
really
listen.
precisely explained.
I've just told you.
You haven't
there is a
explained
difference.
anything.
There's a difference
Yeah,
between
difference.
one
But
and the other.
what's the difference, Bev? What's the difference, Bev?
It depends how good your pump is, and
What's
how
the difference between vacuum
how much
and,
you need.
When I say 0 bar,
Like
you
when
said, "Oh, it's not only 0 bar; it's
Wait,
vacuum."
Right, if you let me
What's the
finish.
difference between vacuum and 0 bar?
Okay, so when I said we had a practical tool, it's called vacuum cooling for lettuce, right? Now, they set it at the amount of air that they needed to extract in order to get the vacuum or whatever, the chill, down to a certain temperature that they needed to do it. They set that on the machine. You just press the button. You lock it all up and you press the button, leave it for half an hour, and the machine would be done. Right now, other people would do that. I've never been in that process of working out what particular vacuum is needed to chill the food into what particular thing. Or even, have you seen them vacuum sealing units? Well, they just need to suck the air out, right? And then seal the thing, right? Well, how do you know when they need enough? And what's that vacuum? Do you need a number in order to be able to put to that? Or would you just look at it and go, yeah, that's enough?
Oh, I'm asking you actually because I gave you actually a specific number on what kind of pressure is going on that wall. And you're saying, no, it's something special, something magical. You cannot compare.
I know,
And
you so badly want a number, don't you?
Yes,
Yeah.
because that's the only thing. Your word saying, "Oh, it's something magical, it's something special," it means squat to me. I don't know what the hell is special to you.
Okay.
It's useless.
Here we go. I'll give you some. Hey, Beth, if you could pick that up in live stream text, what I put up there, and put it into wherever he can.
Where's that?
The tank.
Okie dokie. Yeah, I'll give it him in the debate discussion. There you go.
See the tank, Funk?
Yes.
Yes. How much did on the inside of that, when they pump the air out, did it take a lot of pressure to make that compress down? Was it the inside that compressed it or the outside of it?
It's the atmospheric pressure which is compressing that tank.
So that tank, the trucker tank that carries fluids, gas, whatnot, 14.7 crushed that, right?
Yes.
So you're saying there's not a lot of force, right?
Well, it's 14.1 psi per square inch, though, so you can multiply that by the surface of the whole tank.
Do you know what the inside got down to before it did that?
It's 0.
No.
0.
No.
Close to 0.
No.
But this tanks are built for containing pressure inside, not the opposite way. It's not built to built to contain.
Yeah, that vacuum at NASA, that one, that's
They
built
to
be the way it should be, right? That's what a vacuum should be built
But
like.
this is actually a good example as to why it's actually rather simple to have a pressurized system in space, because you have you can have a lot of pressure inside that tank, and it doesn't really matter because it's much easier to contain something from being stretched, right? Stretching the metal, you have to rip basically the tank apart.
It's just the opposite, dude. It's exactly the opposite.
No.
That would turn into a balloon until one of the joints failed, and then that'd be it.
If you pressurize that tank, the positive pressure, it's more pressure on the inside of the tank than it is on the outside. in the ISS, it's more pressure inside ISS than it is on the outside. Same thing.
Exactly.
Yeah, and it can contain it perfectly fine, right? The tanker can contain more pressure inside the if it's more pressure inside the tanker.
You think if the
Then on the
ISS was
outside.
really up there, they could float around with 14.7 psi on the
Yes.
inside and a 0 or close to 0 on the
Yeah,
outside?
it's 14.1. It's like containing 2 bar in your tire.
And yeah.
Thank you.
I imagine it because you could have a like a space suit as well, containing 14.7 pounds. I mean, it's easy, right?
Yes. You can, I don't know why.
I like to see what that spacesuit's created out of. You know, the layers of the.
You have
The fabric and stuff like
you
that.
posted the evidence now, Redman, actually, as to
Wait.
why it's
Hold up.
much
I wasn't
simpler.
done talking.
Like, for example, a submarine,
done
it's
talking.
has a completely...
Go ahead and finish your thing. I'm gonna say what I'm gonna say.
Yeah, sure. Oh,
You
I
done?
thought you were going to talk first.
Oh, okay, yeah. I'm gonna go and talk now. So, if that thing can compress and it can hold, you know, a great amount of pressure inside those things, I wonder what the layers of the spacesuit is made out of. Is it made out of aluminum? I'd like to see that myself.
I'm not sure what it's built out of.
All right. It looked like fabric to me.
It's
You like
probably,
fabric
I
to
think
you?
it's like made out of some Kevlar stuff or something, probably.
So, the Kevlar itself is airtight.
I don't know. I can check if you want to.
You ever
What
play with
what do you think
Kevlar?
it's what do you know what it's made out of, Renan?
I have no clue, but it looked like fabric to me.
Okay, so then we are both in the same boat. I don't know either.
Okay. Well, this is what I'm saying. If you're saying it looks like Kevlar to you, do you know any
It could
Kevlar
be.
that's do you know of any Kevlar?
I would say it's irrelevant because regardless of what
Why?
I'm gonna say, I'm just guessing. So rather
Okay,
than
so
guessing like you and me are doing now, I'm gonna check what they build it out of.
okay, go ahead and check what they build it out of and see if it's air pressure. And have a demonstration of them in a vacuum.
I'm not gonna look for that, but I'm gonna find out what it's
that's
built
cool.
out.
I want to look for that.
So I've missed most of this conversation. So what did you have you come to summarise what you've been talking about, you guys?
It comes to 1 bar, which is 14.7 psi. What we breathe in, that's not that much. I showed them a tank, getting the air sucked out of it, and the tank compresses. Metal tank. If you look in live stream, spot on, it crushes.
You can't have gas pressure without a container.
Yeah, that's where we were. Funk came in and asked me
Please,
about a vacuum, right? First of all, and
Yeah,
then
I
once
saw
I
that, yeah,
once
I
I
saw that.
explained what a vacuum was, he then wanted to know what pressure was. We then proceeded to agree that the only way you could measure it would be to see a difference between one side and another, between a container or a barrier, and then
Yeah.
and then we decided that again you could never have a negative because one side would always be pushing on the other, and if there was no difference you would then call that 0, and then there may as well not be a barrier there in between because they would both be the same.
Okay, yeah.
That be right, Funk? Would you be agreeing at
Yeah.
that point? Yes.
I agree to that.
Okay, then we went on to decide that a vacuum chamber here, in reality, the place where we live, can't really establish a zero because there's just not enough technology or the ability to really, because you need massive pumps and big concrete walls and all of that in order to do that.
Yeah.
And then Funk said, yeah, but that's just one. There's only difference of one. And it's cool. You can... It's not much, really. I mean, he can put 2 bar of pressure in his car tyre.
Right.
So that's the difference of 1 bar. And that's all he imagines the difference between what we live in and nothing.
I did check what the bar they make. They are able to make 1/1000th of a millionth of a bar in that NASA vacuum chamber. That's the lowest pressure they can make.
Okay, and what's the supposed space?
What altitude?
The one where do us ISS supposed height, 250 miles is that, and give us the moon as well. Give us 2, please, so we can see the difference between them. Remembering that it was 1/10,000,000th of a bar in the one that you said.
That's a lot of zeros.
Yeah, it is, isn't it? Especially if that's what you're starting out as here on Earth, because it's an exponential growth, isn't it? Isn't it meant to be? As far as I knew, I think it was. Because it'd have to be exponential for you to get to 1/10,000,000th of a bar.
What is exponential? What are you talking about now?
Well, go on. What's the bar at the ISS supposed?
I haven't found yet.
Okay. Moon? Have you found the moon?
I did actually read an article on how many. I don't think it's.
Can't be that much because it got
probably
doubled when they
measure
opened
it.
the door.
Yeah, on the moon. Yeah.
So does that mean if they opened the door and released 1 to the moon, would that make the moon have 1? Or would it be 1 divided by, I don't know, some sort of theoretical area?
If it's 1/1,000,000th of a Tor.
Oh,
and
a Tor.
you multiply that by 2. What do you have then?
I don't know. What are you doing?
Still very small number, right?
Yeah, go on. What have you got? Are we dealing with? Is that a Tor? You just changed. We were 1/10,000,000th of a bar.
Or you can say let's say you have 1/1,000,000th of a bar on the moon surface.
1/1,000,000th. Well, so
2.
they can in NASA they can make it 10,000,000th. So NASA can do a better vacuum than supposed on the moon.
I said if you create 1,000,000, I'm just making an arbitrary number. If you have 1,000,000,
you're just making it up.
Moon,
Were you making the 10,000,000th one up that NASA could do as well?
No, that one was one I got from their website.
Could NASA be making it up?
It's pointless to actually discuss that even.
Okay.
That's the only thing.
So have you
unless
got
any of you are working at NASA? Then
okay. Have you got any moon things? Actually, isn't it? Didn't Scott Veach do a paper on atmosphere on the moon or something? Did I not?
I have read
hear
an
that?
article on. I have read an article on this. I gotta go now.
Do you reckon was it Scott?
I gotta go.
You've got to go.
Yes, I gotta go.
Okay. Is that because we were talking about Scott? Or
yes, that's why.
Okay. Scott called you away.
No, my family is home, so I gotta go and make some dinner.
Okay. Nice chatting.
Goodbye.
Pop back anytime.